Good evening, everybody. My name is Peter Lyons. I'm the convener of Renew in the ACT, and my colleague who's just hiding is Pete Gorton, who has been on our committee as well in Canberra for on and off for many years. Thank you for joining us on this webinar, and we're going to be talking about buildings, homes and bushfires, which is a bit different from our typical themes. Before I introduce our speakers, I'd just like to do the little welcome to country. Renew acknowledges the Ngunnawal people, the traditional custodians of the lands from where this webinar is being introduced by me, but of course it's soon going cyberspace. We want to acknowledge and respect their continuing culture and contribution they make to the life of Canberra and this region. And we also acknowledge all other First Nations peoples around Australia on whose land we gather. And I'll just bring up the bio. We have two very experienced distinguished speakers tonight, Maria Kornakova and Jacquie Jong. So first of all, Maria Kornakova, Dr. Maria Kornakova is a Bushfire Services Coordinator with FPA Australia. She's an architect and a Fulbright Scholar. She has a PhD from University of Melbourne and a postdoctoral fellowship from University of Melbourne and Massey University of New Zealand. And her professional focus is on bushfire risk reduction through better building, planning and architecture. She transferred to the industry to apply practical skills and joined FPA Australia at the end of 2018. Also speaking is Jacquie. She's an architect with H plus H Architects, and she's in Western Australia. Oh, I should have said Maria is in Melbourne. Jacquie's in Albany, Western Australia, and she runs a large regional architectural practice with offices in quite a few places in WA. She's a bushfire assessor, and she's well aware of bushfire risks and the provisions, particularly of Australian Standard 3959. Her practice is very heavily committed to achieving sustainable outcomes in their projects, as well as providing necessary protection from bushfires and wildfires. So thank you very much to both of you for speaking tonight, and I'm going to let Dave, our driver tonight, hand over to our first speaker, Maria.
Hi, Peter. Hi, everybody. Thank you for an introduction. Today I'm just going to share my screen so everybody can see my presentation. Today I'll be talking about demystifying BEL assessment in a relatively few steps. It is a quite difficult and quite lengthy process, and it can get quite complicated, and that's something that I will try to demonstrate today. I know that we've got a mix of an audience, so for some of you might be not as interesting because you've been doing this for a while, but there are probably always going to be some little bits and pieces of information that you just interesting to kind of hear again about it. And if anybody has any questions about BEL assessment, just feel free to ask us a question and then we'll respond to you later on. Does it change? No? Sorry, there's a bit of a technical. So what is a BEL? What is a bushfire attack level or a BEL? In a nutshell, it's just a means of measuring the severity of a building's potential to exposure to an ember attack, radiant heat, or direct flame contact. And as you can see, depending on where the hazard is, you've got a BEL FZ, BEL 40, BEL 29, 19, 12.5, or BEL low. And the AS3959 and what we are going to be talking today about, what I'm going to be talking today about, is how we can identify the bell level that is suitable for your building. So why do we need it? So we need a bell to, well, first of all, just a method of assessing a bushfire risk as such. It is a requirement for the construction of class 1, 2, 3 and associated 10A buildings under the BCA code. The site assessment methodology that I will be going through today, and I think that Julie is going to give a bit of a couple, she's going to refer to it back in her presentation as well. It's been adopted across a range of various jurisdictions, including, I know that we've got quite a few people from New South Wales. So the PBP does use site assessment from the AS3959 and just adopted it and introduced additional fuels type, so additional vegetation type, and extended a little bit the site assessment. And it is used quite often for more than just to determine a construction standard for new buildings. It's also used just to identify the bushfire risk of the wider area. Just to kind of put it a bit on a perspective of where you can find it, or why do we need it? So where does it sit in the where you can find the reference to the AS3959. So it usually sits within the building requirements. So when kind of looking into building requirement in the national context, you will usually have an act, which is Act of Parliament, which is a law and the primary legislation. So if you're looking into your legislative documents, that's going to be your building act or planning regulations, planning act, sorry, which then refer to the regulations. And regulations quite often reference codes and standards. So again, depending on who is looking into conducting a bushfire attack level assessment, who is requiring it, you might come across with a reference to AS3959 in your regulation. It can also be called on directly in the NCC. And it's usually, so the AS3959 standard is kind of sitting in this area, and it required only when it's referenced to by the legislation. So just to make it a little bit less complicated, this is just from my home state. Each state has a different set of it, but in Victoria, for example, in the building code, the way that it sits, we've got a building act which calls onto the building regulations, that then calls onto the National Construction Code, which then calls onto the Australian AS3959 or the NASH standard. So that's where you kind of have to do your site assessment. So other examples, depending on where you are, depending on which state you're in. For example, if you're in the ACT, then your acts are going to be Building Act and Emergencies Act 2004, and then the building regulation colon to the AS3959 is going to be this building regulation 2008, and so on. So that's a bit of a semi-boring information. Now let's get into the more fun stuff of what actually the bell assessment is and what is the methodology. So when we're looking into AS3959, there are two methods. So there is so-called simplified method, which consists out of a number of steps, which I am going to go through. And the second method is a detailed method, which allows for customized inputs. The second method is quite complex in a sense. It allows you, so if you've got you usually would use it, or a practitioner would use it when you've got a very steep slope, which is more than 20 degrees, or when you want to recalculate your fuel and kind of adjust it. So when you might have sort of semi-modified forest. We never suggest anybody attempting to doing anything and recalculating anything without using a suitably qualified practitioner. And I'll talk about them a little bit in the end. And Julie is one of our suitably qualified practitioners. And yeah, that just allows you to do the customized inputs. Method 2 is a slightly easier, but it seems like it's quite straightforward, but again, as I'll demonstrate, it's not. So the first step that we need to do is to determine the FDI. So FDI is a fire danger index, and you can find the reference to the fire danger index in your particular jurisdiction within the AS3959. So for example, if we're in Victoria, it's going to be either 50 or 100. Usually it's kind of a more of a general area is 100. If you're in New South Wales, then again, you've got 150 or 80, depending on which area you are, and ACT is 100. Western Australia is 80, so I think that most of Julie's, some of the Julie's examples are going to be Western Australian. Then the second step that we are doing is classifying vegetation. Vegetation is classified using written and visual description data provided within the AS3959. There are 8 classification plus exclusions, and it is primary governing factor in determining the BEL. So it's one of the most important steps for you to get is to get the vegetation classification correctly. The exclusions that are present is one of the most contagious issues in the industry. In fact, we were just discussing it with Julie and other Western Australian working group that we've got. The problems with practitioners and government agencies looking into exclusions in a different way. So there is a constant need to provide more clarity and practice note and just a good practices to understand what kind of exclusions are they and how you can understand them and how you can apply them to make sure that people do not underestimate the bushfire risk, because it can result in quite tragic outcomes. The reason why it's one of the most contentious issues in the industry is kind of it tries to put a lot of square pegs for round holes. And what I mean by that is it's relatively subjective, because one person can come out and say, oh yeah, that's forest, no, that's a woodland. And I'll show you a couple images where it's gonna, I hope it's gonna become a little bit more clear that it is the complexes, the complications and the complexes of it. So for example, this is forest. As you can see this picture on the left, it does look quite foresty and very overgrown, whereas this picture on the right, it's not the best quality, but there is a bit of a kind of a walkway around. You can see that the canopy is not as, the canopy is a little bit separated, so you can see a little bit of the, a little bit more of the sky. And then this image where it kind of looks like a strip of vegetation. There is a bit of a building behind it. Some might kind of have a look and say, really, is this really a bushfire risk? But yes, it is also considered to be a forest. Next example is a woodland. Woodland is generally, again, there is a description in the AS3959 within the written description and the images. Looking into that, again, kind of a general rule of thumb that it's not a written rule, but the way that we're trying to teach, well, when we use it as example as a training, in the training where kind of a difference between woodland and forest is that you can kind of run through the woodland where you can't walk properly through the forest. This is also examples of the woodland. So you can see that the landscape changes quite significantly, and this is also going to be a woodland, and this can also be classified as woodland. So they just demonstrate the differences between the different, it's the same classification technically, but it does look very different. That's an example of a shrubland, which is a classification C. This is another classification of a shrubland, which can also be classified as a grassland within the AS3959. And in order to understand how and what is the best way of classifying it, what is the most accurate way of classifying it, you need to understand the science behind the bushfire modeling that went into classification of vegetation and what formulas and how it would behave in the event of the bushfire. So again, can't stress this more, and particularly with the last season that we had, it's always a good idea to get a professional who is accredited or suitably qualified to do the work for you in terms of the site assessments and classifying it. This is another example of the scrub. Usually it's about 2 meter high. Again, it's very different to the scrub that we've seen before. So just to kind of say, so this can be, sorry, scrub, and this is scrub. Again, this can be grassland, and this is also a grassland. So again, it kind of trying just to differentiate and demonstrate the differences. Next step that you require is to determine your distance between so we went around the site, we've done classified the vegetation. Now we need to identify what is the difference between your building footprint, so between your building site or the elevation and to the classified vegetation. And you need to do it through the horizontal measure from the edge of vegetation to the building itself. And it kind of the AS3959 is full of a little bit of exclusions and a little bit of explanations of how things are done. So when you're assessing vegetation for forest, woodland, and rainforest, classified vegetation should be should be determined by the unmanaged story rather than the trunk. So that's a bit of an exclusion that you need to be aware of. So that's going to be the line of which you're probably going to do the vegetation, do the distances, and this line probably can kind of move a little bit forward. So once we identified the distance, we also need to determine the effective slope. Now there are two slopes when we are looking into site assessment. There is an effective slope and there is a site slope. Site slope is used for the method 2 calculation, so we're not talking about this at the moment. So the slope that we're looking at is this slope under the vegetation. So say we said that this is forest, this is our building, we need to identify this slope. So not this, but this slope. I'm hoping that you see my mouse moving around because I make a lot of comments about that. Yes, so there's a bit of description. So the way that it's you usually, when you do the slope identification, you want to do it beyond the boundary of your assessment. So your general site assessment boundary within AS3959 is kind of sits within the 100-meter radius, maybe 150 meters. But depending on your site, if you've got a very complex site, if you've got quite a lot of slopes, or if the slope kind of goes up and down, you probably want to go a little bit further out just to make sure that, again, that bushfire behavior is properly calculated. So you are calculating all of the steps properly, and that it is as it should be, that you're not under or overestimating your risks. The way that the AS3959 method 1 calculations is doing it, the site is calculated within the increments of 5 degrees. So if it's a 3 degrees, then it's going to be following same as 0, 1, 2, 4, and 5. If it's 6, then it's going to be within 5 and 10, and so on till 20. And it gets really fun when we're talking about the upslope and downslope in AS3959. If you are from the building surveying world, for me, it got quite, as an architect, for me, it got a little bit confusing to begin with. When we're talking about an upslope, it's an upslope not in relation to the, it's an upslope in relation to the vegetation from the building. So if you've got a building sitting here, then this is going to be downslope because the vegetation is going to run up. The fire is going to run up. So there is a bit of a language confusion that might be happening. So if you do have any questions, always refer back to the images. So these are all images from the AS3959. So that explained there. Then, as I said, there is quite a lot of explanations. That's an explanation of how the vegetation, how the slope can be determined, and there is a bit of a explanation with it. What is the effective slope and how you can calculate everything. And then once we've calculated all of the slopes, we've got our slopes, we've got our distance, we know our vegetation, we can then look into the bell tables and determine your bell for your building. So for example, if we had, say, forest, we had it at the downslope of 2 degrees, then we are sitting within the, and our distance was 30 meters, then or 32 meters or 33 meters, then we're sitting within the bell 29. And generally it's an allowed kind of generally that's the bell 29 is the building standard, which is, I think it's a middle ground for most of the states. Depending on your FDI, so you have to make sure that your FDIs are you're looking into the table with a proper FDI. So again, in the AS3959, it's tables 2.4 to 2.7, depending on the FDI that you need to have a look into. So it's your fire danger index. And just to show you an example how the Bell assessment is done with a map, we've done one small map. So this is in Victoria, in Melbourne. This is the site building that we've got, and this is we can see the bit of a contour, so we can see that there is a bit of a steep slope here and there. And this is our 100-meter radius that we've done the assessment on. We went around, and if it's going to start, sorry, apologize. Yep, there we are. We went around, we've done a bit of a classification of the vegetation. We had a look at it, so we could see that there is a bit of a woodland, because it's relatively woodland. It's not really tall. It's quite sparse, and you can relatively run around. It's kind of somewhat managed. Then there is a bit of an excludable vegetation. Apologies for my angle. I had a fun day, I guess. I don't know why it came out like that. And that was excludable. That's just a managed road, and there is a bit of a forest on there as well. And this is how it's going to look like. So we've got a bit of a woodland. That's all excludable. There are different. You can. It's difficult to see, but there is a different plots of vegetation because the woodland is differ depending on the slope, because the slope is changing, so we're treating each of the plots differently. And then we've got a bit of an open forest. This is the distances to the plot, so you can see plots better here. So you can see that, again, that's not the best mapping that I've done, but it was done for students as a demonstration at some point. And that's where we are putting our plots. So we have multiple plots that are affecting the building, and that's all the information that we've collected. And then we're putting it together in a table. So we've got our vegetation classification, so we've got a plot number, we've got a vegetation classification, we've got an effective slope over there, so it's quite slopey, it's quite steep side, the separation distance, and then the bell that it results in. And we've got 7 plots in this particular case, and we have to choose the worst case scenario. So for this particular site, our worst case scenario would have been bell 40. So that's how the bell assessment is done. So I don't know in my time whether I've managed to convince you how difficult it is to get it done. If you're going to start going out and doing it yourself, probably you will notice that there are a lot of questions that can happen, that can arise from this. And we always, as I said, suggest you to use our BPAD accredited practitioners. So FPA Australia has developed, and we are administrating the Bushfire Planning and Design Accreditation Scheme, so I'm kind of running it. It has been implemented in 2006, and it recognized practitioners who can assist the community undertaking development on land subject to the bushfire impact. And we have been in 2006 has been introduced in New South Wales, then in 2012 it was introduced in Victoria, and in 2016 in Western Australia. We've got a national framework approach that then customizes for specific jurisdictions. We are looking into Queensland and South Australia at the moment as well. We're accrediting individuals or practitioners who provide a bushfire assessment, planning, design, and advice services. And all of our practitioners have to meet a specific criteria, which is a training. They have to maintain their CPD points, and they all have to have an insurance, which is quite important for customers when you're getting an advice of somebody. Our accreditation schemes runs out of 3 levels. We do get quite a lot of calls and quite a lot of questions asking to differentiate between the 3. So if we're looking into doing a simple bell assessment, just a bell assessment, that's generally going to be our BPAD level 1. If you require to do a bit more of a planning approach or something slightly more complex, that's usually the BPAD level 2 practitioner. So if you do need to do your DA or bushfire management statement or BMP, so depending on the state, it's all the same. It's pretty much it's a planning approval. all the same but different names in different states, then you will employ a level 2 practitioner. And if you do need to get a bit more of an alternative design solution, so where you've got a very complex site, or if you need to do the method 2 calculations, for example, where you've got a very steep side, or if you've got a lot of vegetation, very kind of a heavy forest on your site, and you want to retain it, or you might have to retain it because there is a significant environmental overlay or some other special protection overlay, then you have to come up with some alternatives. So to kind of work with the fire services and work with the planning or building approval systems, then you will go through the performance-based solution, and that's going to be your BPAD level 3 practitioners. And that is all from me. I think that I've done very quick in terms of time, but yeah, I'm not sure what's, yep, I'm just going to stop share, and I guess the spotlight will go to somebody else. Sorry, Peter, I think that you're muted.
Mute. Thanks very much, Maria.
Sorry, yes, I'll hand over to Peter Overton, and he can introduce Julie. Thank you very much, Maria.
Julie is from Western Australia in Albany, and she'll be doing the section which is more specifically going to be focusing on building design and how to actually introduce construction and fire management measures into the construction of the building. So I'll hand over to Julie now.
Hello, thank you. I'll just see if I can share my screen. So, thank you for having me. As Peter said, I am an architect from Western Australia, and I'm also a level 1 BPAD practitioner. The reason I became a BPAD practitioner is literally so that we could make sure we were designing and building for bushfire protection in Western Australia. For those of you who aren't in Western Australia, over 90% of WA was mapped as bushfire prone, and we have offices in 3 different regions, including the Great Southern region of Lower Western Australia, the Southwest region, which is on the coast, and then the Goldfields Esperance region, which is close to the South Australian border and in Spinifex country. So from our perspective, we're covering all kinds of landscape settings, and it was important that we managed to combine buildings and responses that were responsive to those different climates, as we would for energy efficiency and sustainability purposes, but also for bushfire protection, which is a very important issue in Western Australia. I'm going to talk primarily about AS 3959. In Western Australia, this is the only deemed to satisfy solution under the National Construction Code for construction in bushfire-prone areas. So we come from a very different perspective than potentially on the East Coast, where more performance solutions are explored. What it means is that we have a very thorough understanding of all the ins and outs of AS 3959 and some of the grey areas. This is just an overview of what AS 3959 is concerned with, which is improving the ability of buildings to withstand the impact of bushfires and giving a measure of protection to the occupants as well as the building until the fire front passes. So it is not intended to be that it will guarantee protection of property, it will guarantee protection of life. It's intended to withstand attack. From our perspective, designing and building for bushfire protection covers a number of factors. The first one, which Maria just talked about, is the BAL level. And obviously that's an integral part, because what that does is identify what your actual risk is. So we have a fire danger index of 80 in Western Australia, which is based on our different vegetation types, and there are different vegetation types and bushfire risks in different parts of Australia. The other things that, and the ones I'm going to talk about today, which are highlighted there, relate to site planning, building design and construction standards. The other factors which are very important, but which we don't have time to cover, is landscaping, water supplies, access and maintenance. And all of those items are referred to in AS 3959. And if you ever have a bushfire management plan developed for a subject site you're working on, they will usually take into account all of those aspects. In terms of site planning, I guess from what Maria just said, what you can see is that there are some factors of our site that we can't change, and there's some factors of our site that we can change, and we can always think about how we respond to it. A BAL is determined by three main factors. So you've got slope, vegetation, and separation distance. Sometimes you can reduce your BAL by considering those site conditions and identifying if the house could be better located to reduce its BAL. In Western Australia, under some of our state planning considerations, if you have a subject site and you can achieve lower than BAL 40, the local government will require you to position your house in that placement rather than construct in BAL 40 or FZ, because they're not considered under our state planning policy as acceptable bushfire risks if they could be achieved as lower. So these are really critical factors in terms of achieving the objectives of AS 3959, which is obviously protection of property and protection of life. So with regard to slope, I've copied some of those same diagrams that Maria included. Obviously, it's really challenging. We can't really alter the slope that's under the vegetation that is classified, but we can consider how close we are. You'll see I've got a little diagram here that shows an example of an analysis I did for a client who was looking at the placement of their house in relation to classifiable vegetation, of which there were multiple plots on that site. And what we were trying...
Hi everyone, just while we're getting Julie back, my name is Jacquie Cleary. I'm here tonight to talk about one of Renew's new projects that's coming up. I'll probably give you a bit more information about it later on after the speakers, but it's rebuilding for climate resilience. So it was probably a good opportunity to come along tonight and talk to you about that and the project, the resources that we're working on, the events and so on. And obviously lots of crossover tonight with the speakers that are here, and I'm busily taking notes from the presentation at the moment. There's lots to learn about BAL and so on, and bushfire resistant design. I'm not too sure if Julie's back with us yet, so I could possibly go into a little bit more detail about it while we're here at the moment. Might be a good opportunity to jump in and talk about that while we sort out Julie's connection at the moment and her presentation, and give her a chance to catch up again when she rejoins. So continuing with rebuilding for climate resilience, the main activities are to produce a range of resources for those who lost homes in the 2019-2020 bushfires. The resources will assist as much as possible for those looking to rebuild homes and to advise on the best process to get a home that's suited for future climate conditions, including bushfires, floods and heat waves. In particular, we're looking to assist with and to advise on how to build homes that are affordable to build and energy efficient to live in. It's part of Renew's broader climate resilient homes campaign, which is an effort to raise the energy and thermal efficiency and performance of all Australian homes and prepare them better for the impacts of climate change. So we'll be publishing resources and case studies on a new Rebuilding for Climate Resilience website, looking at topics such as site planning, bushfire resistant design, reaching energy efficient design outcomes, meeting BAL requirements, and finding the right team of experts to work with. So I guess meeting experts tonight is a great way to start, and how to build that team and so on beyond that. And it's also going to be a resource for homeowners looking for general information on design in bushfire prone areas, or looking to retrofit homes for greater bushfire protection as well. Just quickly, I'll also tell you about the events in the first half of 2021, which are planned for those rebuilding homes, including webinars, speed date, a design expert and sustainability expert. And the speed dating events enable households to connect directly with experts and gain one-on-one advice. And then this will be followed by opportunity for one-on-one consults as well. So basically, we know that there's a broad range of audience members here tonight. It is a Canberra-based event, but we know that there's, you know, over 200 people registered to attend tonight, so there might be some national audience as well. So I guess we're looking for experts. We have experts here tonight that we can call upon to assist with the project, but if there are any other experts out there who would like to be involved, we'd love to hear from you in the development of those resources, and also for future webinars and speed date events as well. Be great to hear from you. And also, if there's any homeowners out there with interesting stories about their own builds as well, we'd love case studies for the website as well. That would be great to hear from anyone to talk about the building materials that you've used, how you've met bushfire requirements, and so on. That'd be great. And also to deliver the project, we'll be looking to partner with councils in bushfire affected areas as well. So nationally, if there's any councils that would be interested in being involved as well, we'd love to hear from you. Or if you just know anyone who would benefit from the project, please put them in touch. So I'll put my details in the chat. You can contact me via jacinta@renew.org.au or via the national website, renew.org.au, but I'll put those details up as well. And I think that Julie might be back, and we'll just see if she's ready to keep going with her presentation as well. She's on the phone. So it's a sign that she's receiving some technical advice at the moment. There's also, maybe it might be a good chance to actually, Maria, if you're available, or Julie, how are you going there? Are you okay to keep going, or are you still resolving some issues?
Yeah, I think, can you see me again?
Yeah.
Yeah, I think I'm back.
Just for everyone watching, we're going to do a Q&A
okay.
at the end after Julie's presentation. So I was just about to jump to a quick Q&A with Maria, but if you're ready to go.
Yeah, I'll see if I can resume. I'll just see if I can share my screen again. Back in, everyone see me? Yes, great. Okay. All right. So, sorry, that was welcome to the internet of Western Australia. So, as I was saying, this is important when we're doing site planning, is to consider our separation distance from our classified vegetation, as well as the slope. And as Maria was explaining, there are differences in terms of where the house is placed, whether we go upslope or downslope, and that can impact on your BAL. So it's important to consider house placement at that time, and to take the advice of your bushfire practitioner in that regard. This is an example of a project in the Fitzsterling region of Western Australia. This building is a field station, and it has a residential component, which is how it got picked up under AS 3959, and was actually one of the first ones to be constructed when that legislation changed in Western Australia, which, as Maria had outlined, is only really 2016 that it came in for Western Australia in earnest. This project actually ended up with only 12.5, despite being in what was quite a high bushfire risk area, with mountain ranges some distance away, but we had a mixture of vegetation types, including shrub, scrub, and mallee mulga and woodland. What was key with this project was actually locating the building in a natural clearing, so that we didn't have to impact on existing vegetation types too much. Particularly important for this project because it's an entirely off-grid facility designed for bush heritage, who obviously have strong environmental principles and didn't want to be out bulldozing land to build their new field station, which is focused on the Gondwana Link project. So what was key here was actually getting good solar orientation, getting good placement of the building with consideration of all those site conditions that are important in building design, with prevailing winds and those sorts of things, which were also going to assist in achieving resilience for the building design through its placement. We also Obviously, we're targeting particular kinds of vegetation. So we had some grassland here, which they were able to manage. That was the vegetation we could get closest to. So it's a good example of just that initial process of site planning and using natural clearings. This is the same project, so you can see it in context of the different vegetation types that are there. It really helps demonstrate how important it is to design an appropriate building. We've got careful site planning, we utilise natural clearings, we specified non-combustible materials, and as we go through the next phase, which is about building design and material selection, you'll see how important that is in terms of compliance. We also had to protect key habitation spaces. So as I mentioned, for this particular site, they're out there tracking their restoration work. So it was critical that the works we did to manage bushfire risk, and that included adding firefighting tanks and access and egress tracks to allow for safe evacuation, didn't impact on habitation for local species. We also needed to respond to the local climate conditions. We had to maintain the existing environmental qualities and manage asset protection and safety of occupants and fire responders. So a critical component of planning for bushfire is also making it safe for those fire responders to get into the site to assist in suppressing fire or rescue and leaving as well, which is a critical aspect for site planning. So another aspect of site planning is obviously of bushfire resilience is building to last and selecting materials that are robust and low maintenance and that respond to all aspects of their conditions and environmental setting. As an architect, my favourite part about AS 3959 is it demands a site responsive approach, which is not mandated anywhere else in any other construction guidelines or standards. And although that means for lots of people that they get frustrated that they might end up with a different BAL rating to their neighbour, what it does mean is that it highlights the importance of considering every site for its own merits and its own risks and designing appropriately. So we should all celebrate what opportunities this provides us. So some key considerations of bushfire resilient construction. So I'll go into building design now. And one of the examples you can see here is a local example from Bremer Bay in Western Australia. It was done by architect Ian Weir and was another first cab off the rank in Western Australia for designing for bushfire design. He has experimented with a number of these key factors of the exposed subfloor space versus slab on ground, having unlined eaves versus enclosed soffits, the use of non-combustible claddings, the careful use of timber and combustible materials, positioning of windows and doors, the location of outbuildings and consideration of that 6 metre setback, veranda structures, minimisation of gaps and response to site topography. So one of the key factors I think is material selection, and we need to keep in mind at all times that although the standard outlines what materials are non-combustible and suitable, all materials have the potential to fail in a bushfire. And we have to resort back to thinking, what is the purpose of the material use? And it's to provide resistance and resilience in a bushfire. It's not intended to be fire resistant in the same way that we sometimes have for other components. So it has a different performance standard, which I'll refer to later. So traditional masonry is obviously non-combustible and meets all the requirements up to BEL FZ, provided that weep holes are screened. But remembering that many older brick buildings have open wall vents that can be vulnerable to bushfire attack. Other materials, so these are some examples on the left there, actually done by H&H Architects in Denmark of Western Australia, which is a forest region and very high bushfire risk, and has recently been the subject of a Briggs report identifying that the whole town is of extreme bushfire risk. We utilised this project, it was BEL 19 with hempcrete construction. Hempcrete can achieve a FRL rating of 60, 60, 60. And as any of you who know the flammability requirements for BEL FZ and 40, they require 30, 30, 30. So hempcrete is considered a compliant external wall system. and also obviously is quite a ecologically sustainable material that achieves excellent thermal performance as well. Straw bale construction is a bit trickier. It needs to be a tested system that complies with 1530 regarding flammability, on the basis that the outer cladding is not a solid material, that they usually just put on a lime render over top of the straw bale. A standard render finish to a straw bale house is not considered compliant to AS 3959. So usually you could have straw bale if you put it in conjunction with an approved and BEL rated compliant wall system that would usually include another material applied externally to protect the straw bales. Rammed earth construction is considered an earth wall system, so provided that the external walls meet the minimum 90mm thickness, they are compliant with AS 3959 all the way up to BEL FZ. Rammed earth, as we know, can have poor thermal performance in terms of having insulation, so it usually requires a second wall leaf to achieve thermal insulation and thermal mass. And particularly in our climate, which has a lot of rainfall as well, usually the external walls do need to be protected by eaves, overhangs or verandas because they can erode and in exposure to weather. So it is a compliant solution, provided it meets all the other objectives of the National Construction Code. Likewise, Hebel blocks or aeroclave concrete meets all requirements up to FZ, completely non-combustible and non-flammable, and used in a range of panel or block systems that can be readily adapted for bushfire construction. Timber. So the important thing to understand about timber is that timber can be used in all BEL levels. What's important to understand, which is the usual question I get asked from builders and BEL assessors who come from an environmental background, not a construction background, is how do we deal with lightweight timber, for example, H3 pine, which is very popular in our part of the woods for construction. So treated pine stud walls and trusses are suitable in BEL construction, provided they're protected by an external cladding that is non-combustible. So you don't need to have bushfire resistant timber as your internal wall structure if your internal wall structure is protected by an appropriate cladding. It can be more challenging to use it on exposed structural elements to the subfloor, verandas, those sorts of things, unless they're protected or separated by a fire rated system. So sometimes when we're designing with exposed treated pine or timbers that aren't considered bushfire resistant, they're considered sacrificial part of the building. And so long as they're not acting as a fire source feature and I guess destroying the bushfire resistance of the main house for the lower BALs, it's appropriate that you can use those to create your decks and verandas and pergola structures. Bushfire resistant timber may be used in unenclosed subfloor spaces, but only up to BEL 29. The ones that are listed that we frequently use over here is meerbow, blackbutt and spotted gum, none of which are local species. So our only local species are jarrah and curry, which are very strong hardwoods in Western Australia, but only approved in horizontal applications as bushfire resistant timbers, and have been, you know, sort of slow. As a West Australian, I can tell you the AS 3959 feels very Eastern oriented with all its timber specifications. So your normal favourites like Western Red Cedar can only be used up to BEL 19 if they are installed more than 400mm above the ground. So they're not suitable for subfloors or extend down to the slab level. They can be used in some window frame assemblies, but again, the critical area that they're looking at with the BEL ratings is in that lower 400mm of the wall. And in that area, we usually recommend that you've either got the bushfire resisting timber in the lower BEL levels or a fully non-combustible lining to the subfloor. Obviously, the reason for that is ember attack and the fact that you can get a build-up of material which is flammable from your garden or those sorts of things in a bushfire that can push embers into your subfloor and make the rest of the building vulnerable. So that's why they're not appropriate in those applications. So bushfire resistant timber can be used to clad the exterior walls up to Bell 29, but can't be part of Bell 40 or FZ unless they're sacrificial. So there's an example there, and there's a lot of really great resources for building with timber in bushfire prone areas. The featured house here is actually mine and was on the front cover of Fire Australia with regard to timber construction in bushfire zones. That's clad with Jarrah. So it's only a Bell 19, but it is possible to use timber and still achieve the aesthetic or the sustainable outcomes that you're looking for, depending on your timber source. But externally, it's usually part of a broader fire-rated wall system, which has multiple layers, including fire-resistant plasterboard in the wall system to protect the interior from radiant heat and ember attack. And there's some examples there that I've included. So more common non-combustible lightweight materials is profiled pre-coated steel or fibre cement or magnesium oxide board, which can all be used up to Bell FZ and are very common in that regard. It doesn't mean that they won't fail in fire. As we know, they are affected by heat just as much as anything else. But again, they're intended to be resistant to the attack of fire in the flame front and not be combustible. They do require a sarking to the roof end, to the wall materials, which is again for ember attack. Most of the National Construction Code leads everyone to think that sarking is a requirement, but we do see builders not necessarily using sarking in all walls. But it's great with bushfire construction is that sarking is required as an ember guard, and then the cladding is fixed over. So obviously it helps with gap sealing and being that extra layer of protection. And again, there's plenty of examples that are available for those fire-rated wall systems using sarking. I just wanted to mention about gap sealing. It's very interesting in the code that we are required to seal up all gaps. So here's where we find the interface between the National Construction Code and AS 3959, and they don't necessarily work together very well, particularly when we're looking at subfloor ventilation or roof ventilation, because of the requirement to put mesh over all grills and exhausts and those sorts of things, which have a maximum aperture of 2 mil. Now that is intended to protect from radiant heat and ember attack, but it can have some unintended consequences, and people need to be conscious that we can't just design like we always have with subfloor vents or roof venting and then cover those up with a fine mesh like that and not think that there might be impacts on airflow. This also shows some examples there of the extra efforts that are needed to seal up, for example, a profiled or corrugated roof sheet around windows and sheet ends to make sure that we meet that requirement for gap sealing. So I know in Western Australia, we don't have a standard for construction tolerances, but it's fairly well accepted that 5 mil might be an acceptable construction tolerance. But AS 3959 mandates that we're basically working at 2 mil because that's the maximum gap size. That has some impact. So here's an example of a Bell rated 19 residence that was constructed to meet the code and had some unintended outcomes by sealing up all penetrations and putting that perforated mesh on the exhaust fan. So they've got considerable condensation issues that they're now managing. The builder felt this was caused by the fact that he had to install the rock wool at the ridge and sheet ends, which ultimately removes any of that old traditional leaky air syndrome that we had. But it has exacerbated condensation because he doesn't have an active ventilation system in the roof or in the exhaust fan. So these are some of the unintended consequences. Likewise, these are some examples that I've taken from site inspections of projects where these are all low, like Bell 12.5, with a contractor struggling to achieve the 2 millimetre gap requirement and also using inappropriate materials. So there you can see he's literally screwed in a piece of plywood to fill up his gap which is obviously combustible in itself. And there's a lot of challenges for average builders to achieve the high levels of compliance that AS 3959 requires in their industry, and understanding that gap sealant needs to be non-combustible too. Also, when we've got subfloors, obviously we often end up with penetrations that come through the subfloors, particularly for plumbing, and consideration needs to be given fire stopping those areas. So what you can see here, it's all under one house that was Bell 29 constructed. The deck was constructed using bushfire resistant timber on top, the Merbau, and then they protected the subfloor frame with an intermescent paint. So that was considered part of a performance solution to achieve bushfire resistant timber. You can see the classic effects of Merbau staining there as well. But the critical thing, I guess, is the number of penetrations that come through a typical subfloor and the extra effort the builder had to go to in terms of lining the underside with a non-combustible sheet lining to protect it. There's also lots of gaps in AS 3959 that aren't covered of building components that might come up. So I've got an example there. We had a Bell rated property where they had an external composting toilet, which had a penetration, and the builder ended up constructing a fire resistant enclosure that still allowed for the protection of the system and the sealing up of the subfloor, but was extra work involved for them. We've also had details where we've had to create, for example, the awning window on a Bell FZ house to make sure that that wasn't adding to the bushfire failure, I guess, of creating new seals or having, combustible materials on the outside. So those are just some examples, fencing, screening, things that can come up that AS 3959 can be silent on. So what you try and do in those circumstances, from my perspective, is obviously understand the intent of the code and use that to guide your decisions. There's also other building elements that we know can assist in the survivability of a construction during a bushfire, but then are not recognised as compliant solutions under AS 3959, and one of those is bushfire sprinklers. So I get this question all the time of people saying, oh, we want to invest in getting bushfire sprinklers. It's not a compliant component of AS 3959. So that's just something that you need to keep in mind. Roofing, so obviously we know that we're typically using roof materials these days anyway, which are non-combustible. The critical factor that most people don't recognise is the requirement to fire stop the profiles, and that means more than just using your normal contraband strips that close up the eaves. So we're having to put non-combustible rock wool insulation at the sheet ends as well as at the ridge and any other penetrations. And particularly for higher BAL ratings like 40 and FZ, the roof structure also needs a layer of ply underneath the roof sheet, which can obviously add considerable amount of cost. It's intended to assist with ember control, and it can obviously have some great benefits energy efficiency wise, but it is a big impost that affects the cost of roofing for the higher BAL ratings. The other key thing is that the roofs need to be fully sarked. So I've been to some projects recently where, the sarking has been cut around setback gutters, skylights, all of those sorts of things are considerations we need to think about, because the roof is obviously playing an important role in protecting the building, particularly when you look at the shape of flames that are coming in a bushfire front that are hitting the roof as well as the walls. So it's important to have a look at that. We usually specify and do similar details to these ones that I've shown here in our construction documentation, so that the builder is very clear on where the rock wool needs to go and where the ply is required, and also the sealing up of eaves. As you saw from those earlier photos, it can be difficult to achieve a sealed soffit without an eaves lining, particularly at the wall and roof junctions. Windows and doors are also an important component. You'll see a lot of discussion about those in AS 3959 and their location in relation to the ground or decks, and that's because they're vulnerable. So glass is very vulnerable to heat, radiant heat effects. And so we've got provisions in there that relate to glazing, that relate to the materials that can be used in the frames, and also protection of them with either corrosion resistant and fire resistant screens or bushfire shutters. This is an example of a Bell 40 protected window that's got a shutter that comes down and all fully sealed up against bushfire attack. Not always the most attractive aesthetic that you're looking for. There were some of the compromises. There are also Bell FZ rated window systems available. I've listed 2 brands there, Parhammer and Nilfire, that we've used before, that mean that you can retain your aesthetic. Their prices are way higher than normal glazing because they are made from, the frames are steel and the glass is ceramic and toughened and tempered. So it's important to understand that you can achieve the aesthetic, but it can be at a very high cost. Obviously, it achieves great things in terms of your thermal performance and energy efficiency of those windows, but it can be a big cost impost. Bushfire shutters can also be used, and I've included some examples here of bushfire shutters that we use to protect external veranda spaces as well as windows and external walls. And, you know, they have some design advantages, I guess, in terms of insect protection and those sorts of things that can be desirable. And there can also be ones that open up either from the sides or the top, like a casement or awning, to protect windows. But they're quite an obvious feature that you'll see on bushfire designed houses. And now I just want to quickly touch on how AS3959 interfaces, I guess, with the National Construction Code. So I've included an excerpt, which is that obviously a deemed to satisfy solution for any building of Class 1 or Class 10A located in a designated bushfire prone area is to construct it to AS3959 or to the NAS standard. This does not, I've not included here all the exclusions that apply with New South Wales and those sorts of things, mostly because it doesn't apply in my life and we're literally building to AS3959 for deemed to satisfy. I've just included here the NAS standard. That's suitable up to Bell 40 only, and is based on research done by CSIRO and detailed testing to test the construction requirements for steel framing. Wood Solutions also has some excellent resources relating to building with timber in bushfire prone areas, and I strongly recommend this if you're in a region that uses timber framing as opposed to steel framing. And they've got excellent resources about timber species and application of appropriate details. There was the old Handbook 36, as it was called, which was published in 1993, but just kept as a draft. That's still out there and available, but it's probably better to use more current systems. Here, I just wanted to go through some of the key interfaces of the National Construction Code and AS3959. So one of the key parts and key questions we often get is to do with fire separation. Now, just referring to Class 1 buildings, many of you will know that when we're looking at fire separation between what are called fire source features they're much more lenient in terms of the building, in terms of being either 900 or 1800 mil separation required to prevent transfer of fire and fire spread across buildings. But when we're talking about AS3959, to facilitate fire separation between residential buildings and adjacent structures, they mandate a 6 metre separation distance. Otherwise, that adjacent structure, which we're usually talking about sheds or carports or granny flats, they must be then constructed to the same standard as the main residence, so they can't be excluded. So that's just a funny aspect that's different between the National Construction Code and AS3959. Condensation management, so I touched on this previously. Obviously, the NCC requires mitigation of condensation within a building, and the deemed to satisfy solutions are generally focused around water barrier membranes to external walls. And they encourage the use of sarking to manage air leakage and thermal performance. AS3959 also requires the use of sarkings as a continuous barrier against ember attack. And depending on the climate zone, one thing to be important is whether or not it should be vapor permeable or impermeable, because obviously impermeable sarking can often contribute to condensation, and potentially in climate zones where it may not have previously been an issue. The NCC also has some guidance regarding exhaust systems to be discharged to outdoor air or to ventilated roof spaces. But then what we have is the AS 3959 requires those vents to be covered up with mesh, which may impact on their operation or their effectiveness. So that's something to be considered, and it may require that you need professional advice regarding ventilation. So part 3.10.5, construction in bushfire areas, the NCC identifies that the deemed to satisfy solution is to comply with AS 3959 or the Nash standard, although there are some performance solutions available in other states. A critical one I just wanted to mention there is about bushfire shelters. They're classified as class 10C under the NCC, and they're usually only considered appropriate for Bell 40 or FZ sites or on vulnerable developments. But it is not recognised as a deemed to satisfy solution under AS 3959. So we often get clients saying, well, rather than building the house, why don't we just build a little bushfire shelter and that will be our compliance solution? That's not accepted under AS 3959. There's also the building code has prepared guidelines relating to private bushfire shelters, which is just guidelines. So I would not recommend you using those unless you feel competent in their application and potentially get approval from your local building or your local building surveyor, your local government, as well as a bushfire practitioner, as it's really part of a performance solution on the whole site. And there's some key factors in that guideline to do with the separation distance between the bushfire shelter and the main residence and those sorts of things that you need to take into account. They're not as straightforward as planting a bunker in your backyard. The other one that obviously interfaces, which I've mentioned before, is to do with the energy efficiency. The good news is that many bushfire prone areas are cold in winter and hot in summer, and they already require passive solar design response, thermally efficient glazing and thermal mass, all of which is mandated by AS 3959. So a lot of the time, the things that you're needing to comply with for bushfire, you're already needing to comply with under this section of the National Construction Code to achieve minimum compliance. There are definitely gaps, and in Western Australia in particular, our state government has been slow in mandating the latest version of the National Construction Code, which gives some builders the ability to use earlier editions where they're just using that comparative building and not having to do all of these requirements. So then they're stinging consumers with extra costs associated with bushfire compliance, which really should have been covered with their energy efficiency performance. So an overview then is for designing and building for bushfire protection. Really need to understand the BAL applicable to the site. Can it be reduced, and can the house be better positioned to reduce bushfire impacts and environmental impacts? Design an appropriate building response and incorporate the right details. Does the construction method and style of building suit the site and bushfire requirements? So we have this issue in our zone where we've got mountainous regions and people want to build pole homes. They're not always most appropriate for bushfire construction. So you've really got to think, is this the right site for that home? Are materials selected for their resilience and suitability for construction in bushfire prone areas? And have suitable construction details been incorporated to minimise ember attack and impacts of radiant heat? Certify compliance. So this is something that many builders don't realise, but when they lodge their notice of completion, they're basically agreeing that they have constructed the building in accordance with AS 3959, if that was mandated as part of their building permit. So if in doubt, builders should always seek advice from a professional who understands the code, and that could be during construction at the end, and potentially liaise with their building surveyor about that. I often do inspections on behalf of builders and provide reports back to building surveyors because I obviously have some experience in construction that allows me to assess whether or not something's been constructed to the code or the intent of the code. But, you know, not everyone is going to have that, feel that confident. Lastly, obviously, recognise the limitation. The standard is designed to improve performance, but it does not guarantee safety and does not guarantee the survivability of the place. So we always recommend as well that people have other plans in place that will allow them to safely exit the building, and that staying in the building should also be considered a last resort and not always the best solution. So I guess in summary, from my perspective as an architect, site responsive design should already be taken into consideration, and including all the aspects that we look at for BEL, which is topography, solar orientation, prevailing winds, shading, sun protection, thermal insulation, thermal mass, retention of environmental features. All of those aspects are important in bushfire and important for environmental and site responsive design. We should already be considering the suitability of materials for their durability, their low maintenance, and their appropriateness for different environmental conditions, and bushfire should be considered in one of those. And building to AS 3959 is generally just good building practice. It prioritises resilience, durability, building performance, and site responsive design. So I guess from my perspective, we should be encouraging people to build to this standard. I don't know if I've got time, maybe you could nod at me, Jacinta, to just cover, I've done a quick case study that people might find interesting about the retrofit of a existing single-storey beach shack.
I think people are so interested in your presentation, so I think you should go ahead. I wouldn't want to stop you, so I might get some comments from the audience if I were to. So, but also we're also mindful there are a lot of questions as well.
Great, no worries. There's only a couple of slides here. So I just wanted to include this one. This was a project that we worked on in our office. You can see from the photo here, this was the absolute classic Australian bush shack. It was made of recycled materials, timber framed with asbestos cladding, a dodgy old roof that had been sourced from sheds, an exposed subfloor, very steep site. When we first classified this site, it was actually FZ. The clients went back and did vegetation management to create a larger clearing around the site and reduction in fuel loads. And we managed to get it down to BEL 40. And then ultimately did a retrofit to this building to try and bring it up to code. So you can see an example. This is what it looked like when we started. So fairly low quality construction. This is the result. So you can see in the first instance, the setting has changed somewhat in that we've managed the lower fuel. We've sealed up the subfloor. We've changed the external claddings. We've upgraded all the windows. We have put bushfire shutters on. We have sealed up the soffits and replaced the roof. The subfloor has vents in it. And all of these things have been done to retrofit to BEL 40. There's some examples there. So this was the one that I showed previously that's got the bushfire shutters on the verandas. They really wanted to protect the whole building, so we could have put those bushfire shutters onto the windows, but they wanted them on the veranda, and it creates quite a nice space for them in their everyday activities of keeping the flies out when they're having a barbecue. So hopefully that gives you a good overview of sort of what you can do to an existing building, even when it looks like it's a lost cause, which was certainly our first advice on that one. And that's it. Questions?
Over to you, Peter, for the questions.
Thanks, Jacinta. Thank you very much to both Maria and Julie. They're incredibly informative talks from both of you, and also many thanks to Jacinta for filling in the gap there when the WA internet decided to give us some trouble. We've got quite a lot of questions here, and we won't be able to get through them all tonight, unfortunately, but we will be attempting to answer all of the questions after the event, even ones that can't be directly addressed tonight. So if you don't have your question answered immediately in the session, don't worry too much. We'll be able to get to you. We'll start off with one from David. It's addressed to Maria. And he says, in the Manningham example, in the Manningham example, you had an area defined as excludable. Can you explain what is meant by this and why the area was identified as such?
Where the road.
This is relevant to us as we have been rated flame zone on a site in the town of Bright. Neighbours are at Bell 29.
Yes, thank you, Peter. Yes, David, the excludable vegetation, so within the AS3959, there are 8 excludable areas of vegetation. If you're in Victoria, there is also managed land. It's in the specific example that I showed is just a road. So that gives you an extra separation distance. Depending on how far away you're sitting from the hazard and how far away your neighbor sits on the hazard, that might be the reason why your bell is different. There also might be slope differences and distances. It's quite difficult to comment on a very specific question like such as yours. But if you're unhappy with your bell assessment, you might want to consider getting somebody else's advice. Maybe have a look into the other practitioner who can help you out with it. And I can, while I have you, there were a couple of questions about where to get a standard. Do you mind if I'll quickly swing by and show that?
Mm-hmm.
So AS3959 is Australian standard, which is not available for free usually. It's quite expensive standard, but they did publish it for free. It's available till July, I think. So if you're going to go into the SCI Global and just have a look into AS3959, you can just Google AS3959 2018 SCI Global. It'll take you to this page. If you will get a hard copy, you'll see that they cost about $256 each. But if you'll get one PDF, you can download it. Well, it's going to prompt you through the steps. You can download it. And I think that that's going to answer a few questions that we've got over there in terms of where to find it. So just for people out there.
Okay, second one from Kristen. Our property has been assessed. Oh, yes. Yeah. No, sorry. I've got the wrong ones. It's from Nyan. We already had that one. If I'm from the supply side, and this is from the point of view of a window supplier, who actually is responsible for providing the bell rating? I understand the NCC does not allocate responsibility. However, interested in your thoughts, if it is the council, the homeowner, or the builder responsible for providing the bell assessment rating. So with respect to building products, I think this is referring to.
So depending on the state, but usually it's the, well, it's the homeowner's responsibility in the end of it, because they're the ones who are doing the rebuild. But then you're going through the different systems. So if you're getting a planning kind of advice, then that the planning permit can have a bell report in it. So I'm not sure where this, if you're looking from the perspective of marketing, I don't. Julie, do you have an additional, because it's different in states, I think. Yeah.
Yeah, no, so I understand the question. So I think the responsibility really for getting the bell has to be lay with the homeowner, because as Maria said, they're the ones who are seeking to build a house or to change an existing residence with substantial modifications. Sometimes developers will provide preliminary advice, and they might have a bell contour plan which indicates that if you build your house here, it's going to be 19, and if you put it there, it's going to be 29, for example. But the bell contour doesn't replace a bell report, like an actual assessment. And so the assessment comes when you've got a real house plan that you can lay on your real site, because they want the actual separation distance to vegetation, which can't be generic. So it has to be based on a real site plan and you know, an intention to build there. So from that perspective, clients can't really influence the bell practitioner. No one should be able to influence the bell practitioner. What they should do is they should engage a bell practitioner who provides them with advice about their bell rating. They might provide them with advice that says, if you did some additional vegetation modification, which is particularly useful if it's their subject site, then you could get a lower BAL, or if you located your house slightly differently, you could get a lower BAL. So it's always in the homeowner's interest to have that BEL practitioner working for them. And then basically they provide that information to the builder or to the council. You know, sometimes builders obtain the BEL practitioner, but you really want that person working for you because it's your property and they're acting on your behalf.
I think you may have also been referring to building products manufacturers in the question as well, and they're actually responsible for providing their own ratings.
Yeah, so that's right. They have to get the testing. So there's existing standards like the one I mentioned to do with the flammability index. So you'll see some of the large companies, they actually pay for that testing to get done and be verified and certified. And that's what building surveyors are going to ask for. So the example I mentioned with Jarrah in Western Australia is it meets the density requirements of bushfire resisting timber, but it had to be verified in certain applications. So some of the suppliers got together and funded the testing. And that can be where the challenges lie. So those fabricators or suppliers of material, if they want to sell BAL rated products, they have to have the verified testing to substantiate that. And you certainly never want to agree to having a BEL rated window going into your place that's not certified for BEL rating.
Thanks, Julie. This one is probably also to you. What are the considerations for installing solar power in lower intensity BEL areas, including batteries?
Yeah, so if the solar panels are going on your roof, we all know solar panels are generally non-combustible, and the main consideration is going to be just making sure their install doesn't contribute to hazard on your profiled roof sheeting. So part of that is dealing with the penetrations that might go through if there's a fixing to make sure that that's adequately dealt with and doesn't create a gap in the roof. And that likewise, that the way that the panels are installed, you don't have the ability for, you know, leaf matter or those sorts of things to build up, similar to how you might need to manage your gutters and those sorts of things. So you're not creating a hazard on your place. And then the connections through to batteries. So it's similar to other external services where you might have hot water tanks or you might have gas bottles and other things that are external. My advice is if they're a hazard and you can, locate them away from your house because you want your house to be protected, and that's the intent of the code. But it is challenging with ones that need to be co-located right next to the device, for example. But if you, for example, had a storage shed that's got all your battery backup in it, and that's attached to the building, it's going to need to be designed to the exact same standard as the rest of the house.
This one probably for Maria. Our property in Brisbane has been assessed as flame zone, but with some minor vegetation management, we have been advised we can design to BAL 40. The assessor has also talked about a performance solution. Just wondering if you can explain a bit more about performance solutions and what they actually are. Well, perhaps both of you can
Sure.
something on that.
Sure. So probably just looking into the question, I'm guessing that they would do a method 2 calculation, or they would do a different assessment to the site than to a straightforward. So the performance-based solution is a designing of the solution that meets the same outcomes that the deemed to satisfy solution, but just using different ways. That probably would be a fair and quick response.
Yeah, it's like any, so, you know, the National Construction Code is made up of what are deemed to satisfy solutions and what are performance solutions. So, you know, deemed to satisfy is if you do this, you comply, and it's very
like a recipe.
Yeah, it's very straightforward. And that's where the majority of building lies. But when you've got performance solutions, you usually require them to be certified by another professional. So if any of you have ever worked in commercial construction where we might need fire engineers, and you're looking at performance solutions on fire protection or separation, you often need that to be certified by a proper fire engineer. It's not something that your architect or your builder is going to feel comfortable certifying. So it's really just taking it to a higher professional level with someone who's got adequate training who can say that meets the performance requirements.
I've always wondered, and I'm often asked, where in AS 3959, if at all, that the concept of sacrificial cladding is permitted. Is it something that is expressly permitted or just acceptable practice? There's actually a couple on that one.
Yeah, so it is acceptable practice in there, in the sense that ultimately, it was in one of the examples that I showed when I was talking about timber, where you could have a fire rated wall system, for example, that achieves the 30-30-30, although most of the rated systems are actually 60-minute rated systems, and that you basically clad the outside with a timber or a material that's combustible. And it's recognised that that timber itself is not necessarily going to impact on the structural integrity of the main structure. So it wouldn't be acceptable if it was integrated into the structure. So that's why we talk about subfloor and wall framing being different to, and roof framing being different to external cladding. So you often see that in those approved fire rated wall systems, particularly for the higher BALs, that you can do that. But otherwise, AS 3959 is quite clear on which BAL you can use combustible materials on the walls and what distance they need to be off the ground.
Julie? During your presentations, very interesting cases have been mentioned regarding the application of technology and materials. However, the interfaces are still affected by bushfires. In your opinion, what are the pending key elements for the development of urban interface planning? Are they really prepared to face bushfires? So that's, yeah, just on the preparation, I guess, the town planning scale preparation is the question is being there.
I can only comment from a West Australian context, because this is picked up with our state planning policy, which states that for any new subdivisions, if the BAL rating or the bushfire hazard is 40 and above, it's not acceptable for residential development. So state planning policy 3.7 in Western Australia states that that's not applied retrospectively to lots that are already approved for residential, and that's where the challenge has come. And I noticed this in Western Australia, regional WA, where we have a big backlog of people who bought a bush block in the 70s down on the coast, and they've sat there and left it, and then they're finally at a stage where they want to build their shack, and they're caught out by new bushfire planning provisions, and can get in a difficult situation then, because sometimes those blocks are landlocked and they can't achieve the requirements of access and egress, and you know, basically the local government will put lots of controls on them. So it will say, okay, you can do a house here, but it can only be in this building envelope, and you have to have a bushfire management plan. So what that does is it transfers the cost back to the owner, the landowner. I think moving forward with urban development in those areas, we need to be identifying what areas are unacceptable hazards for residential development and stop building in them, and manage that land differently, and not put people in them, I guess. And it's difficult to do that because there's always people in a community who want to live in those kinds of places. And in my zone, we have a lot of those places that are very remote, one road in, you know, that people want to build their amazing hideaway in. So I think it'll constantly be a battle for that. But particularly with, you know, new urban development, I think in our state, I feel like they're doing the right thing in terms of having broad scale bushfire assessments of new areas, but there's still always tricks. And one that's happened in West Australia recently that we've been looking at is the, you know, industrial developments where the local government requires them to revegetate a large portion of the site. And so the bushfire assessor goes in there and says, well, if it's revegetated, it reverts to forest and you're back to FZ. So, you know, you do need that careful interface of how do you achieve good environmental management in residential areas. And yeah, I think that we've still all got a long way to go with that.
Thanks, Julie. Another one for you. When complying with Bowel flame zone requirements, how does the cost of shutter solutions compare to improved glazing?
Yeah, I've had this quoted twice. The bushfire shutters in 40 and FZ are expensive and complex solutions. The glazing still costs more, in my experience, because it is not as readily available. So there are probably more bushfire shutters suppliers and solutions available in Australia than there are window systems. And the window systems that we've used, like the Parhammer one, had to be imported. So I think they're still very high end. In fact, I did a article in the Fire Australia, I think FBA might have that on their website too, Fire Australia magazine, which shows sort of the cost comparisons across those different bell levels if people are interested in looking at that.
Right. Okay, this is another one concerning site appraisal, maybe from Maria. Another property is being assessed as flame zone. There's a minimal chance of fire approaching from the south and east in this case. Can we make an argument for these two sides of our planned house to be rated as Bell 40 while the other sides remain a flame zone? We are interested as we could then use Bell 40 rated windows in the south and east.
Generally, you can use, so there is a allowance for a shielding within the AS3959 standard, yeah, but it's again, it's a case by case.
Yes, yeah. So there is provision, I think it's section 3 in AS3959 talks about shielding. It's usually only available on
one side.
one elevation.
It's only one elevation. You can't do it on two elevations.
What it does is it drops that bell. So it might mean if the rest of the house is FZ and that elevation is sheltered by the remainder of the house, that side might be able to drop down to bell 40. So that it works in each way where it's potentially dropped down. And your bushfire assessor can usually provide some advice about that in their assessment as to whether shielding provisions may be able to be applied if you're not sure about the interpretation under AS3959, but it does permit it. And shielding can also be achieved with performance solutions using colour bond fencing and things like that to help protect a building from the direct impacts of flame.
Okay. Maria, can a bell determination be imposed in development applications for land that is not declared bushfire prone?
It can, but very, very unlikely. No, if there is no bushfire in Victoria, no, it can't. In Victoria, it's almost everything is bushfire prone area. No, it has to be a bushfire prone area because that's how it calls on into the standard. But as Julie said, it might be a good idea.
The only thing that
use
can
it
happen
for something else.
Yeah. The only thing that can happen is that map can change. So
that's there as well. Yeah.
The local government has the ability to request modifications through like Department of Fire Emergency Services to change the bushfire map. And that's happened recently in the metro area in Perth, where they have excised a portion out of the bushfire prone map, which to me suggests that it could be political, the outcome, that could happen in a local government area because it's only affecting that local government. So yeah, those things can change over time because that bushfire map is not static.
Right, thank you. This one I think is referring to differences in the assessment level across a site. He's asking, from Nick, he's asking, so if only 10% of the transect is a worst case scenario and the other 90% is much lower risk, will the worst case scenario still apply?
Yes, that would be yes, wouldn't it, Maria?
Yep. Sorry, yeah. I've got it. Yeah. Sorry, to the previous one, I've actually didn't probably cut you off a little bit too quickly, Peter. For the Bell FZ, shielding does not apply. We've just been corrected by, yes. It was a Bell FZ, sorry. I've gone through Bell 40. I thought that was the question. Yeah, if you've got a Bell FZ, then shielding does not apply. You can't go down to lower level. Thank you.
Okay, from Ian, I saw rainforest briefly in Maria's Bell table. Obviously it can burn, but what approximately was the factoring down? That was it really. How much does that reduce the fire danger factor?
The rainforest?
The rainforest. Yeah.
It doesn't really reduce the fire danger index. It's just it can reduce the fuel load, but then you have to go and do the calculations for it. Contact somebody who can have a look again into your specific question. It doesn't influence fire danger index at all. So fire danger index is something that's set for the state or for the specific area. It's a specific set of, it's an algorithm it's a mathematical model, essentially of various, of just severity of the potential fire in the area. And you can't just say that's a patch of rainforest, patch of forest, therefore FDI for this square hectare is going to be different. So.
Okay, thanks, Maria. Yep. There's one just asking to reiterate the sacrificial timber principle, but I think that got fairly comprehensively answered before.
If you were really interested in that, I recommend going to the Wood Solutions slide that I showed, that guide to building in bushfire prone areas with timber, because there's a lot of information in that, and Wood Solutions has a really good website where you can get lots of information about that.
Thank you. How are we going on stamina? We're up to 8:40 now. Are you speakers interested in taking a few more questions? Or
Yeah, I'm happy. Yeah,
okay,
if everybody else is fine. Yeah.
Okay.
Maybe. Yeah.
We'll press on. Maybe for another 10 minutes. How would that be?
Yeah,
it's fine.
Fine with you? Okay. I have a question about a specific building product called Fire Crunch. Does anybody have any experience with this? Promoted as low carbon monoxide emissions, it's got here. Fire resistant to 90 minutes, termite resistant, flood resistant, and all good things by the sound of it. So anybody heard of that one?
No, I don't know if it's marketed as a fire resistant product or a bushfire resistant product, but they are interchangeable. As I mentioned earlier, the bushfire resistance level, which is the FRL level, relating to structural integrity, etc., of the product, the requirements are actually lower. So if it's a 90-minute rating, it'll more than achieve the requirement for AS3959 for those materials that are required to have a 30-minute rating. So I would think that.
And if I can just add to that, if you've got any questions about any material, it's usually a good idea to contact them and ask for their certificate. So if they have been gone through the testing 1530.8 part 1 or part 2, depending on whether which bell level they are, they'll get a certificate from either Warrington Fire in Melbourne or CSIRO in New South Wales. So there are two testing materials, so two testing facilities that test different bushfire products.
Yeah.
Thank you. Question about verification here. We know that there are issues with our building approval system. Is this a real issue with houses? Now, I guess by this is meaning the whole bushfire assessment process. Is that an issue as built as opposed to what's being planned into the building at the documentation stage? So,
yeah, definitely.
Feelings on that?
Yeah, so we have this issue in Western Australia. I assume it's the same across Australia, where traditionally we used to get residential projects were inspected by the local government's building inspector, who would certify compliance and give occupancy certificates for Class 1 buildings. With the privatisation of certification processes, basically now the builder is the one who lodges his completion and in essence is saying that he has built it in accordance with all relevant standards. which can include AS 3959, which is usually dictated either at planning or building permit stage as a requirement to meet. So absolutely it is a risk, because sometimes, as you saw on some of those photos I showed you, despite their best efforts, sometimes builders just can't get it right, and they misinterpret the intent of the code because, you know, it's not necessarily well understood and it's outside of normal building practice and tolerances. So definitely there are risks that builders can't get to the required standard, and the added risk for consumers is that there's not necessarily many people who will go and inspect on their behalf and inspect for that. So if you're someone who is building and you can get a building surveyor or an architect or an engineer or someone who has some experience in understanding the application of the standard, it's probably better to get them involved before completion, because a lot of the issues are actually during the construction phase. So, you know, the ones I usually see is that they forgot to put the rock wall in under the roof sheeting, and obviously it's quite an exercise to try and remediate that after construction is completed.
Yeah, probably the whole industry, just about all areas, really, isn't it? Now, question here, ideas for cladding and roof materials. Do you have suggestions on or guidance for also for decking materials to achieve BAL 29?
Yeah, so your roof materials are your standards in terms of tile and profile steel, pre-coated steel, those sorts of things. So they comply with all the requirements provided they've got that sarking underneath. I think the only material that is probably at risk, which we don't really use much anymore, is timber shingle. Is the only one that would really have some combustibility issues and compliance issues. And then with your decking, you've got to look at your decking two ways. So you've got to look at your subfloor of your deck and whether or not it's integrated into your main building structure, because that might determine that it needs to be made of bushfire resisting timber, which is usually, you know, your heavier hardwoods or things. Or you'll see in that example I showed with BA29, they used a H3 pine butt with intermescent paint, which is a fire rated paint. So your decking material on top will again be dictated by what BEL rating you've got. And usually the higher the rating, the more robust the material. You know, there is like ones that we popularly use is Merbau is often suitable right up to 29. But if you're looking for a decking that is higher than that, so there are some of the composite materials, there's also fibre cement decks that are available that achieve right up to 5 FZ.
Thanks, Julie. We have a 2.5 metre, there's one from Kristen again. We have a 2.5 metre deck and intend to enclose it with fire resistant steel mesh. The door and windows would therefore be set back 2.5 metres. We've been told that we can use normal windows in this situation. Have you come across this as a solution before?
Yeah, so we had a similar project where someone wanted to, they had a semi-enclosed swimming pool and they wanted to enclose it with a mesh to protect the internal windows and those sorts of things. And it's similar to that example I showed in Lowlands that was the retrofit. We used a bushfire shutter. So provided the mesh, so it's about an interpretation of where the external wall lies and whether or not those windows are fully protected. So yes, you could technically use the a normal window as long as it's protected, depending on your BEL level and whether or not the operable as well as the fixed portions are protected and at the building line. So, you know, you'd want to make sure that mesh is not just protecting the window, but is that a continuous barrier to the subfloor part of the deck? What are the posts made of? What is the roof made of? Those sorts of things, so that, you know, you've got a fully integrated solution, I guess. So that look at all the surrounding components too in that solution.
Thanks, Julie. Another question from Nyan. It's concerning ceiling materials. Going through the gap ceiling materials slides as related to flammability index. What is the flammability index? So how is that assessed for the ceiling materials, I guess, is the thrust of it?
Yeah, so most of the materials that are acceptable for use in those external ceiling materials are listed in AS 3959, and on standard your 4.5 mil fibre cement is acceptable provided that the joints are sealed and sealed back against the wall and to the underside. So that's the most obvious material that people use for soffit lining. Where you might have issues is using lighter timbers like cedar and things like that on those material locations, depending on your bell rating. So, you know, because you can still have an exposed eave with your exposed rafter if the junction at the wall and the roof is sealed up. So there's sort of solutions there. It's just if you're going to line your eave and that protects your roof structure and your wall structure, it needs to be non-combustible.
Right. One of the issues for clients is the financial impact of bell rating. Are there any guideline or information on this issue? Obviously, it differs on the size, location, design, etc. of the building. Is there a relative cost to, well, I guess they're asking if there's some sort of a guide or assessment of how the cost increases as it's linked to an increase in bell rating.
Yeah, so that was the article I mentioned that I've written before that's published in Fire Australia, and I think I've sent that to you before, Peter, if you wanted to share it with the chapter.
Right.
It was looking at a conventional construction type in terms of being slab on ground with different verification, you know. So it was basically looking at what did that building cost, and it was a real project that we actually built. What did that building cost when it was bell low, i.e. no AS 3959 provisions, and what did we have to do to upgrade it to each BAL level and what changed? And what you could see in there is the costs were progressively going up, but minimally, but it was on the basis that we had an appropriate construction method in the first place. So what you would see is a greater impact if you had a more challenging construction method. So obviously, if you've got a slab on ground brick construction with an iron roof, you're already starting at an almost compliant solution once you deal with your windows and your gap ceiling. So it just depends on what your base building is as to how big the impacts are going to be. Yeah.
Now, one from John Blight. The best design solutions for buildings are those that respond appropriately to sustainability, energy and fire performance and generate their own aesthetic in the process. Most home builders and town planners are still driven by preconceived and outdated notions of style, federation and so on, as the primary design driver with the energy and fire performance measures bolted on. Do you see any hope of this aspect of the Australian psyche? This is a very deep question. Changing sometime soon in the interests of a better built environment. Okay, we've got at least 10 seconds to answer that.
Yeah, my short answer is no. The issue is, in my state, architects do 2% of housing. So while 98% of housing is done by the project market industry, who upsell stone bench tops, not thermal performance and durability and resilience, and they're working to low design lives of 7 to 15 years instead of 50 years, we are fighting a losing battle. What we really need is for government to mandate higher standards of construction that weed out lots of the crap building, and AS 3959 is good in that sense of it's the first one, as I said, that really says do a site responsive design, and what your neighbour's got doesn't matter, you know, it matters what you've got, and it does overlay with some of those energy efficiency provisions. There are always loopholes, and the lowest common denominator builder will always find those loopholes and continue to deliver inappropriate solutions. But I think if you're prepared to fight the good fight, I'm the same. You know, it's soul destroying sometimes to see what people do, but you've just got to continue to educate people. Like, think about what has changed in the last sort of couple of decades with education around water-wise gardening, for example, and the mindset that that has resulted in with people changing their behaviour, and you don't see people hosing down their driveways anymore. So, you know, we just got to fight the long fight.
Yeah, indeed.
Okay.
Now, perhaps we should make this possibly our last question.
It's Peter here. Yes, Peter, maybe we'll make this the last one, seeing it's approaching 8:55.
Time is wearing on. Okay, we'll make
Outstanding question.
this the last one. We did have one question concerning wind effects. It was just basically a general one, but possibly worth addressing in terms of how wind actually affects the considerations of the overall envelope design. So perhaps either or both of you could have a go at that one.
Yeah, I think, Maria, you could probably address, you know, in terms of when you're doing the bushfire assessment of understanding prevailing winds and the likely direction of fire fronts is something that BAL assessors often consider, particularly in the higher levels.
I think that you've answered it perfectly just now.
Yeah. Yeah.
But yeah, no, but the structure, the AS3959, something happened to my video. I'm back. AS3959 does allow for the idea is that the envelope, that the building itself is a sealed envelope, and if you do have an ember coming in, then AS3959 unfortunately does not really protect from that as much. Nash does, AS3959 doesn't. And I also wanted to make a side note. Nash actually does cover BAL-FZ buildings as well, construction as well. It's probably not as widely available in Western Australia, but it's an alternative for the construction.
Yeah, and my only other add-on to that question, Peter, is that as a designer, people do need to think about their building form and what impact their shape of their building footprint can have in regard to prevailing winds, particularly with the build-up of fuel potentially against the building that can contribute to how it performs in a bushfire event. So what I'm thinking of is, you know, sort of inverted corners and spots where material can gather, that in a bushfire event, particularly with prevailing winds, means that embers get thrown into that area and trapped into that area, and it becomes a hotspot for combustion. So, you know, we should always be thinking about prevailing winds when we're doing site responsive design, in terms of providing shelter for habitation generally, but thinking that we're not going to design a wind tunnel that captures embers as well.
Sure, well, that's a good answer. Thank you both very, very much for providing all this information. It's been fantastic, and I'm sure Peter and Peter both agree. It's been a very, very well worth presentation.
Yeah, I agree. Thank you, Maria, Julie, Jacinta, and Dave for presenting and running this. It's been wonderful. The unaddressed questions, we'll see if Maria and Julie can address those offline. We're conscious that not everybody's questions got answered.
No problem.
Thank you very much.
I'd also like
Thank you.
to add in a big thank you to Peter Lyons and Peter Overton for their organisation of tonight, and the Canberra branch generally. They've done a great job pulling such a fantastic event together.
Yes.
The audience have loved it. Lots of great chat and questions, and the Q&A has been fantastic as well. And also, yeah, again, thanks to Maria and Julie. It's been a really great session. Thanks.
Yes, it has. And thank you to Peter Overton for initially approaching Maria and Julie. It's been terrific. Thank you.
Thank you.
You're welcome.
Awesome.
Good night.